Hi guys, today I'm going to show you 7 causes of generator electrical power failure and how exactly you can fix them yourself. Number 6 will surprise you because it's something you most likely overlook. It might please you to know that I've been working in this field for over 8 years, so everything I will show you here is based on real practical experience. If you're using champion power equipment, Generac, Westinghouse or any single phase AVR portable generator, then pay close attention. Please note that on this channel, we don't waste money on repairs like electrical repairs. We fix it ourselves safely and professionally. Let's get started. Number 1 on the list is circuit breaker. Before electricity reaches your socket, it must pass through the circuit breaker. Now, under fault conditions, the breaker trips and stops power from flowing out. But sometimes the breaker itself becomes faulty. Here are some of the signs of a bad breaker. The switch won't stay on. You switch it on, it falls back off. 2. There's no continuity between the breaker terminals, whether it is on or it is off. When there is no connection between the breaker and the socket, normally there should be continuity between the breaker terminals and the socket. When there is no continuity between these points, know that your breaker is bad. And this is reviewed by a continuity test with a multimeter. How do you confirm? There must be continuity between the socket and the breaker terminals. Please remember to do this. Remember to conduct this continuity test when the generator is off. Now, there is one last important test, very important. Simply bypass the breaker just by shorting the terminals. After that, start your generator with no load. Then after some minutes, add a little load and observe. If your gen runs smoothly, just install a new breaker and that's it. But if your generator vibrates aggressively, struggles or sounds overloaded, please switch off immediately. This indicates that the breaker has been protecting a deeper fault. We'll get to that later. Number 2 on the list is AC socket. You're already familiar with this. Some of the common problems is widened terminals. The terminal can widen due to use of bare wires instead of proper plugs, and this can lead to poor contact. Number 2 is burning and overheating. Due to much load or loose contact, the socket can burn. And in more severe cases, there can be short circuiting when the insulation melts and the conductive terminals of the socket touches each other. It also happens when you use bad plugs or bare wire. The wire can get stuck inside and short the 2 terminals. Remember, when there is a short circuit, your breaker trips. There could also be disconnection from the coil. How do you confirm a socket problem? Under normal condition, there should be continuity between the 2 socket terminals when your breaker is on. Now note that if continuity exists even when the breaker is off, please know that the socket is shorted. Remember to always put off your generator before conducting continuity test. Number 3 on the list is brush. This very component supplies DC excitation voltage from the AVR to the armature. It is made of graphite and conducts from the slip rings to the coil of the armature. Just in case you don't understand this whole concept, excitation, and all of that, in order not to make our video lengthy, I've clearly explained everything and more in this ebook that even a toddler can understand how a generator produces electricity. You learn how to solve all possible problems of your generator electrical issues step by step. You can see details about brushes in page 44 of this handbook. I'm going to leave a link to this book in the description of this video. It's really going to be helpful. The next on the list is AVR. AVRs are dual functional. They rectify excitation voltage and also regulate the output voltage by varying the amount of DC it sends to the armature. You can see in this video, by varying the input, the output also varies. AVRs can fail for so many reasons, and each cause requires different solution. Number 1 is simple wear out. Due to usage, it can get old. And what we should do in this case is just a simple replacement. Some symptoms of a worn AVR include delivering excess voltage, very low voltage, or no voltage at all. Sometimes you can see visible physical deformation of the AVR, just like what you can see on the screen. Number 2, the AVR can be malfunctioning as a result of bad exciter or bad armature. In a generator, the exciter coil feeds the AVR while the AVR feeds the armature. Now here is a bonus. Do you know that your generator can be delivering output voltage and yet the AVR is badly damaged? A good example is the gen you are seeing on your screen right now. In fact, this condition is more dangerous than having a no voltage output condition. I'm going to explain later. Armature. An armature is the electromagnet of a generator. The armature coil receives DC voltage from the AVR. The image on the screen shows how electricity is generated. The armature plays the first role of inducing small voltage into the stator. The stator, through its exciter windings, resends the voltage in a rectified DC form back to the armature coil through the AVR and brush. With this DC voltage, the armature becomes a bigger electromagnet that can induce bigger AC voltage, which the coil sends out to the socket. The major problem of an armature that causes no voltage output is bad slip ring. You can see the slip ring on the screen. Bad coil. The coil is bad when it's open circuited, burnt, weak, or has earth leakage. I have some videos on armature repairs and rewinding. I will drop their links in the description of this video. Number 6 is bearing. This is a bearing. You are probably surprised right now and asking, how does this relate to electricity? But this is the armature bearing. It causes one of the most tricky electrical problems your generator can face. In fact, 7 out of 10 times, a bad bearing is accompanied by what you call rubbing and damage of the armature casing. You can see the armature casing here. When these parts are bad, your generator will either suffer complete zero output voltage or low voltage. I solved a bad bearing problem in the video you are seeing on your screen. Number 7 is the stator. The stator is like a transformer. It's like the transformer of a generator. It is from the stator windings that the induced voltage is sent out to the socket. The stator comprises of different set of coils and wires, and I've carefully labeled all of them on this page in order to keep our video length moderate. Okay, so please visit page 39 of our generator electrical repairs handbook to learn this in details. Okay, one of the greatest challenges you're going to face is how to disassemble your generator, locate some of these parts, the tools you need, and all of that. But don't worry, I get you covered. I have videos that demonstrates how to do all of these things. I will leave links to them in the description of this video, and then also in our book it was treated in details on chapter 3. Trust me guys, there's a different level of satisfaction when you can fix these faults by yourselves. Let me know in the comment section which of these problems you've experienced before, and please don't forget to like, subscribe, and get a copy of our repairs handbook. It will really help you a lot, and it's also a little way of encouraging my work. Links in the description. See you in the next one.